Okay.
Maybe we can just take a field trip to go. We can take one of the school vans.
I'm cake for you on that.
We'll do cake lab Wednesday. We'll do Kimberly's birthday Thursday, and then we'll do pie day Friday.
Bingo.
Okay, you have a plan. I don't even know why I need to come. You guys will plan the class for me.
We got it.
Okay, so what's going to happen when we rotate around an axis that's not the x-axis or the y-axis? What if we rotate around x equals a? All right. We are going to have to think about, like, if this is our region, I draw in our rectangles with thickness dx. How far away are each of those rectangles from x equals a? Think about it first. Maybe discuss it at your table before we bring it up to the whole class. How far away are those rectangles from x equals a? Max, how far away are those?
A minus.
Okay. We said that this distance was what? X, right? And what is this distance right here from x-axis, or excuse me, this is the y-axis, to x equals a? That distance is a. So this distance right here, just like Max said, is a minus x. Okay, we have to think about how far away each of those rectangles are from our axis of rotation. Okay, so that's very good. Now, when we're on the other side, if we're going to rotate around like x equals negative a, we'll have to adjust a little bit, and we'll do an example so we can see that. But we have to adjust our radius based on where our region is in relation to that different axis of rotation. Okay? Nothing else is going to change about our setup. It's just going to be the radius portion that we have to adjust. Okay? So let's go ahead and look at this example. We have y, I don't know why I have y equals, it's just 4 minus x squared, but y equals 4 minus x squared, x equals 0, y equals 0, and we're going to rotate about x equals 2. So write down what you need to, draw your region and your axis of rotation. Maybe draw in your rectangle also so that you're ready. This is what your picture looks like. We have, and I'll highlight it in green. This is our region right here, right? And we're going to rotate it about x equals 2. So then if I create a rectangle with thickness dx, okay, we're going to create shells, right? These are parallel to the axis of rotation. We're creating shells. Imagine that rectangle popping up out of the page and rotating around that red line. Okay, we have these shells. So 2 pi integral, our region goes from 0 to 2. We need radius, we need height, and we need dx. So let's first worry about the height. That's the easy part of this. That's the familiar part, maybe I should say. The height of each of these rectangles, top minus bottom, is just the 4 minus x squared because it goes to the x-axis. Top minus bottom is just the 4 minus x squared. Okay. If we were rotating around the y-axis, our radius would be x. But now that we've changed it to x equals 2, we need to consider how far away each of these rectangles are to the axis of rotation. Okay? Well, we know that this distance from y-axis to rectangle is x. So if I'm talking about this distance right here, if each one of these rectangles are x away, then this is going to be 2 minus x. So you can still kind of think of it as right minus left for that distance. 2 is on the right, okay? And each of these are x away from the y-axis. So 2 minus x is that distance. You have a question?
Well, yeah, what if it was on the left side of the, or the y-axis?
Okay. If it were on, let me see what my next example is. Okay, our next example is going to have one like that. And so, can we take a time out and I'll answer that next? Okay. Other questions about the setup? Math 9 is that boy. Let me know what it is. Ooh, that was quick. Trenton had his calculator out. He was ready to go.
I think you should be in the calculus speed.
Yeah.
I would not.
You have the speed.
I
You
would
just
get,
showed us.
well, I was doing it.
Oh, you're working ahead.
I would get shown up. I would just be bored. You're in the class. Unless you're bringing it. Yeah.
You'll carb load right before by eating pizza. So you're gonna be ready. Don't die.
Well, I gotta do the thing first.
Sure. That's
I gotta
sure.
qualify.
All right. Let's talk about what happens when our axis of rotation is on the other side of the y-axis. So here's my example for that. Not that. Here it is. Okay, so here's really our bundt cake example. And this is kind of what we are going to do next Wednesday. We're going to create a region using quadratics for our bundt cake. We're going to rotate it about an axis. But this is definitely an equal sign, not a minus. Okay. So f of x is 3x minus x squared. We're taking that and the x-axis, I was looking for it, thank you. And we're going to rotate it about the line x equals negative 1. So please graph the parabola intersecting the x-axis. Draw your line x equals negative 1, and then we'll get ready to set this up. Okay, so here we have our region. Here, I'll put it in red. Here's our region, and we're going to rotate it around the axis x equals -1. So can you kind of imagine like that butt cake for me? Can you picture it, this twisting around? Okay. We all know what a butt cake is now, right? You figure that out? So, if we have, and let's think about this. Do you really want to try to do this in terms of what? I would not. Okay. Trying to split this into 2 square roots, like it's not going to work. We want to stay in terms of x. So, luckily we have the shell method. Otherwise, trying to use the dishwasher method would be really ugly. Okay? So, we have our rectangle with thickness dx. So, we have 2 pi integral. Our region goes from 0 to 3. We need radius times height dx. Okay? The height of each of those rectangles, top minus bottom, is just 3x minus x squared. But when we talk about the radius, I want you to think about how far each of those rectangles are from the axis of rotation. But it'd be the other way. Really, we're talking about x minus -1 or x plus 1. Okay, if we think about it, you can think about it 2 different ways. Right minus left, these are x away minus -1. Or you can think about how this distance is x, and then we are adding 1 to get to the axis of rotation. Okay? So this is what it's going to look like when we're rotating further to the left than just the y-axis. Trenton's got to work on his speed. You beat him to it.
45 times. I'd be tired.
Oh. Are we up for one more example?
Anyway.
Be very careful how you draw this picture. Which direction is this parabola opening? To the right. And which way is it shifted? Left. Right. Up to. So if this were y equals x minus 2 the quantity squared, it would be shifted to the right 2, like you said. But since we inverted it, x and y are switched, we also have to invert our direction. So instead of right 2, we switched x and y, and now it's up 2. And y equals -1 is what we're rotating it around. Now, before we set anything up, okay, we probably need our points of intersection. Okay? And I don't want to lose our algebra skills, so let's go ahead and do this algebraically. We want to know where y minus 2 the quantity squared intersects with y. Right? In order to solve this, if maybe your picture's not great, you really can't tell, you don't want to guess and check 15 times. How do we go about solving this? Yes. Then what? Subtract that y over. Minus 1, minus 4. Okay, so our intersection points are y equals 1 and y equals 4, and really that's all we need. Okay? Because I think it's going to be in our best interest to keep this in terms of y, since that's how these equate, well, because we're doing the shell method, but it's going to create less work for us if we keep this in terms of y. If we try to do this in terms of x, we would have to split this up into two different integrals because our bottom function would switch partway through. Yep. Now it's too. Okay, so we know that our limits of integration need to go from 1 to 4. Since this is a parallel rectangle to y equals -1, we are talking about the shell method. So 2 pi, radius, height, thickness. The height of our shells is always the height of our rectangles. Okay, so now we kind of have to shift. Okay, our rectangles are horizontal, so I need to know how long they are. Okay. Well, we're still doing right minus left. Right minus left, we have the line minus the parabola. Okay, so that's the height of our shells. The radius, how far away are each of those shells from the axis of rotation? That's how we describe that distance right there. Y plus 1. Would you agree with Max's y plus 1? Okay. Do you have a question about why Max said y plus 1? Julia, if I asked, or if your neighbor had a question, why is it y plus 1? How would you describe it to them?
Because it's like the top minus the bottom.
So we describe this as y away minus negative 1. Love it.
63 pi over 2.
63 pi over 2. We've been getting really nice answers, haven't we, today? What? Okay.
Oh,
Oh.
no, I did y, I did x times.
So today, this is the last assignment that you're going to have that focuses on the method. Okay? Again, you're going to have problems that I'll let you do with the calculator, but there's, how many of them I asked you to do by hand? 2? 1? 2? 1 that I asked you to do by hand. Okay? Tomorrow, we're going to focus on both volumes of rotation. Okay? No area, no volume by slicing, just this washer versus shell. But then our test will incorporate all 4 aspects of what we've done. Okay? So what I want you to do is I want you to do 1 problem from your homework before you walk out of this room. Okay? Some of us had an issue getting to our homework last night, so at least you could practice 1, and it'll at least feel better if you, for forget to do it tonight. Okay? Take a picture of the page, just write down the number. I don't care. Okay.
Is our test going to be with
Your test will be, I'm going to say right now, part calculator, part non-calculator, much like your quiz. But that is not 100% certain. My memory could be failing me. Let me check with my records here. Actually, I think your test is all with the calculator.